Now we are going to continue electrostatics formulae and problems, second part. Electrostatics formulae and problems. Second part. Electric field and electric potential. So electric potential work done per unit charge V is equal to W by Q. Work done per unit charge, we call it as electric potential. Electric field E is equal to V by D. If one positive charge is present, another positive charge is moving away from it, then E is equal to minus dV by dr. So V is equal to minus E dr closed integral or integral E dr. Minus sign here because two positive charge, one charge is fixed, another charge is moving towards. Because of repulsion, you are putting a minus sign there. Okay. This is electric potential and electric field relation. Next, electric potential energy. Due to 2 point charges, U is equal to Q1, Q2 by 4 pi epsilon naught R. Electric potential energy of a dipole. That means you are placing electric dipole in an electric field. It experiences a torque, we know. What is the energy behind it? U is equal to minus Pe cos theta. You can integrate this equation from one point to another point. It is rotating. The dipole is rotating. Theta 1 to theta 2 or 0 to pi by 2, 0 to 180, anything. Then in that case, cos theta, theta 1 to theta 2, you can put. Correct? So this is electric potential energy of a dipole. Next, capacitance. Capacitance formula is Q is equal to C is equal to Q by V. Charge by potential. Charge by potential is capacitance of the conductor. For a spherical conductor, CS is equal to or C dash is equal to 4 pi epsilon naught into capital R. We can derive this concept. For a spherical conductor, capacitance of the conductor is given by the formula 4 pi epsilon naught into R. Capacitors connected in series. One by CS is equal to 1 by C1 plus 1 by C2, etc. 1 by Cn. CS is a resultant or the total capacitance when all the capacitors are connected in series. Here charge is same, potential is different. Capacitors connected in parallel, C1 plus C2, etc. Cn. Capacitors connected in parallel. Here charge is different, potential difference is same. V is same, Q is different. Q is same, V is different. Parallel plate capacitor. Capacitance of a parallel plate capacitance connected in air or placed in air. C is equal to epsilon naught A by D. Capacitance of a parallel plate capacitor placed in air. No, sir. Fully dielectric it is. Entire between the two plates, the distance is D means it is epsilon naught A by D. Fully dielectric, entire D is occupied with dielectric. So that is C medium, epsilon naught, epsilon or A by D. It is not fully dielectric, sir. It is partially dielectric. Total distance is D. This is dielectric of thickness T is introduced. Then the capacitance formula is C dash or C medium dash epsilon naught A by D minus T plus T by epsilon R. Epsilon naught A by D minus T plus T by epsilon R. Okay, so this is capacitance partially dielectric. Remaining is D minus T is air space. T is a dielectric thickness. Correct? So with this basic formulas, we are going to do the problems in this one. Problems. Determine the electric potential at the surface of gold nucleus. The radius is 6.6 into 10 power minus 15 meter. Atomic number of Z is 79. Electric potential due to a point charge. The two things we forgot to discuss in the formula concept. V is equal to Q by 4 pi epsilon naught R. Electric potential due to a point charge. Electric potential due to a dipole. Very important 5-mark question, that is P cos theta by 4 pi epsilon naught R square, where P is called dipole moment. This is for a point charge, this is for a dipole. R square, R cube without cos theta is electric field formula. That's okay. First one, for a point charge, the potential formula is V is equal to Q by 4 pi epsilon naught R. 1 by 4 pi epsilon naught as usual 9 into 10 power 9. Charge given as this is Q is equal to NE. N is ZE in our case. Number of electrons 79 into 1.6 10 power minus 19 divided by R 6.6 into 10 power minus 15 meter. Rearrange 1.7 into 10 power 7 volt. Surface of a gold nucleus, the potential is 1.7 into 10 power 7 volts. Second, the work done in moving a charge of 3 coulomb between 2 points is 6 joules. What is the potential difference between the 2 points? Work done is given. Potential, straight formula. V is equal to W by Q. What is the work done? 6 joules. Charge is 3 coulombs. So 2 volts. Very simple, straight problem. 2 points A and B are located in diametrically opposite direction of a point charge of +2 microcoulomb at distances 2 meter and 1 meter respectively from it. Determine the potential difference VA minus VB. Potential due to point charge is Q by 4 pi epsilon naught R basic formula. So potential difference means VA minus VB is equal to Q by 4 pi epsilon naught is common 1 by RA minus 1 by R. So VA minus VB is equal to 1 by 4 pi epsilon naught is 9 into 10 power 9 into the charge. What is the charge given? 2 into 10 power minus 6. One by RA minus 1 by RB. 2 meters, 1 meter. Half minus 1 is minus half. So 18 into 10 power minus 10 power 3 minus half. So minus 9 into 10 power minus 3. This is the potential difference. VA minus V. Fourth problem. 2 point charges plus Q and minus 2Q are kept at a distance D apart. Plus Q minus 2Q. Distance between them is D given. Find the location of the point relative to the charge Q at which potential it is 0. AB at a distance of x it is 0 means remaining should be D minus x. Similarly, we have done for electric field. Now potential we have to calculate. So Q by 4 pi epsilon naught x plus minus 2Q by 4 pi epsilon naught D minus x is equal to 0. So I can write Q by 4 pi epsilon naught x is equal to 2Q by 4 pi epsilon naught D minus x. Q by 4 pi epsilon naught, Q by 4 pi epsilon naught cancels. 2x is equal to D minus x. D is equal to 3x. X is equal to D by. So potential is 0 at a point C from plus Q charge at a distance of D by 3. Correct? That's what the question. From plus Q charge only they are asking. So D by 3. Remaining means D minus D by 3 you can write. From minus 2Q means D minus D by 3. 2D by 3. Okay. Next one. Problem number 5. Find the electric field between two metal plates which are 3 millimeter apart connected to 12 volts battery. E is equal to V by D. What is the potential given? 12 volts. Distance between the plates 3 millimeter. 3 into 10 power minus 3. So that is 4 into 10 power 3 volt per meter. Volt per meter. Sixth one. An electric field of 20 Newton per coulomb exists vertically downward direction. Determine the increase in electric potential as one goes up to a height of 50 centimeter. This is also a straight problem. E is equal to minus dV by dr. Here E is equal to V by D. This is one formula. E is equal to V by D. And another formula minus dV by dr. Negative sign because both are positive charges. So because of repulsion, you are getting a negative sign. Okay. So dV is asked minus E into dr. Electric field is 20 Newton per coulomb. Dr. Downward direction minus 50 centimeter. So minus minus plus 2 into 5,000 into 10 power minus 2. That should be 10 volt. So change in potential is 10 volt. Okay. Next. An electric dipole of length 2 centimeter is placed with its axis making an angle of 60 degree. The uniform electric field of 10 power 5 Newton per coulomb. If the torque is 8 √3 Newton meter, calculate the magnitude of charge. Any question, first write the formula. Torque tau is equal to PE sin theta. Question is you have to calculate the charge. So tau is equal to Q into 2D is dipole moment P into E sin theta. So I can write Q is equal to tau by 2D E sin theta. So Q is equal to, what is tau ma? 8 √3. 8 √3 by 2D. Dipole of length 2 centimeter. 2 into 10 power minus 2 into E 10 power 5 sin theta sin 60 degree, that is √3 by 2. 2 will go to numerator, 2 cancels, √3 cancels. So 8 into, this is 10 power 5, 10 power minus 2 will become 10 power 3. 10 power 3 numerator will become 10 power minus 3. So you will get 8 into 10 power minus 3 coulomb. 8 into 10 power minus 3 coulomb. Straight. 8 1. 2-point charges 10 microcoulomb and minus 10 microcoulomb are separated by a distance of 2 centimeter in air. Calculate the potential energy of the system. Potential energy basic formula U is equal to Q1 Q2 by 4 pi epsilon naught R. You know very well 1 by 4 pi epsilon naught is 9 into 10 power 9. Two charges 10 microcoulomb and minus 10 microcoulomb. 10 into 10 power minus 2 minus 10 into 10 power minus 2 by R value. R is 2 centimeter. 2 into 10 power minus 2. Simplify, you will get U is equal to minus 45 joules. Because here you have a minus sign. So minus 45 joules is the answer. Straight problem for electric potential energy of the system. Find the amount of work done in rotating an electric dipole of dipole moment 3.2 into 10 power minus 8 coulomb meter from its position of stable equilibrium to the position of unstable equilibrium with electric field of 10 power 4 Newton per coulomb. Basic formula for work done of a dipole is minus P cos theta 2 minus cos theta 1. That is minus Pe cos theta actual formula. Theta 1 to theta 2. So upper limit theta 2, lower limit theta 1. So I can write Pe into cos theta 1 minus cos theta 2. What is dipole moment? 3.2 into 10 power minus 8 coulomb meter. Then electric field is 10 power 4. Stable equilibrium at rest. Unstable equilibrium rotated fully. So cos 0 minus cos 180. So I can write 3.2 10 power minus 4. 1 minus of minus 1. Cos 180 is minus 1. So it will become plus 1. 2 into 3.2. 6.4 into 10 power minus 4. This is work done. So I can write 6.4 into 10 power minus 4 joules. Straight problem. 10th one. An isolated sphere has a capacitance of 50 picofarad. Calculate its radius and charge if V is equal to 10 power 4 volts. Isolated capacitor value 4 pi epsilon naught R. Spherical capacitor. Capacitance value 4 pi epsilon naught R. R to be calculated. So R is equal to C by 4 pi epsilon naught. 1 by 4 pi epsilon naught is 9 into 10 power 9 into capacitance value 50 picofarad. Pico is 10 power minus 12. 9 5s are 45. 10 power 10 minus 12 is 10 power minus 2. So 45 centimeter. Second, you have to calculate the charge if potential is 10 power 4 volts. Q is equal to CV. So I can write C is 50 picofarad and potential is 10 power 4. So I can write 5 into 10 power 5. So 10 power minus 7 coulomb. 0.5 micro coulomb. You can leave it as it is or you can convert into micro coulomb. Both are correct. Correct? This is Q is equal to 50 into 10 power minus 12 into V is 10 power 4. Okay, so this is 10th problem. Next, 11th one. 11th one. Find the capacitance of a conducting sphere of radius 10 centimeter situated in air. How much charge is required to raise it to a potential of 1000 volt? How much charge is required to raise a potential of 1000 volt? Same. This is problem number 11. Capacitance, first you have to calculate. C is equal to 4 pi epsilon naught R. 1 by 4 pi epsilon naught is 9 into 10 power 9. So 4 pi epsilon naught is 1 by 9 into 10 power 9. Into the radius is 10 centimeter. 10 into 10 power minus 2. So 1 by 9. 10 power 9 will go as minus 9 minus 11 minus 10. Coulomb, sorry, farad. This is C value. Simplify, nearly 11 picofarad. 0.11 you will get 10 power minus 10. So it should be 11 into 10 power minus 12. So 11 picofarad. Okay. Next, charge we have to calculate. Q is equal to CV, basic formula. So Q is equal to 11 into 10 power minus 12. What is V given, ma? 1000 volt. So I can write 11 into 10 power minus 9. 11 into 10 power minus 9. Straight from 12th one. When 1 into 10 power 12 electrons are transferred from one conductor to another of a capacitor, a potential difference of 10 volts develops between the two. Calculate the capacitance of the conductor. Given number of electrons, potential difference is given. You have to calculate capacitance. Basic formula of capacitance is C is equal to Q by V. Here, what is Q? Q is equal to Ne. What is number of electrons given? 10 power 12. Into charge is 1.6, 10 power minus 19. So I can write Q is equal to 1.6 into 10 power 7 minus 7 coulomb. Therefore, C is equal to Q is 1.6 10 power minus 7 by what is the potential given? 10 volts by 10. So 1.6 10 power minus 8. Straight problem. Straight sub. Okay. So this is the 12th problem. 13. A capacitor of 20 microfarad is charged to a potential of 10 kilovolts. Find the charge accumulated on each plate of the capacitor. Straight again, Q is equal to CV. C is equal to Q by V. Previous problem we have seen. Now Q is equal to CV. What is the charge? What is the capacitance? 20 microfarad. Potential is 10 kilovolts. So 10 into 10 power 3. So I can write 2 into 10 power 5 minus 6 is 10 power minus 1. 0.2 coulomb. 0.2 coulomb. Okay. 14th one. Three capacitors of equal capacitance, when connected in series, have net capacitance C1. In series, what is the formula? 1 by C plus 1 by C plus 1 by C. Equal capacitances. Three capacitance. Net value they have given C1. So series formula 1 by Cs is equal to 1 by C1 plus 1 by C2 plus 1 by C3. In our case, C1, C2, C3, all the three are same. So we can write 1 by C plus 1 by C plus 1 by C. That is 3 by C. So C1 is equal to C by 3 farad. In parallel, net capacitance is C2. In parallel, C2 is equal to C plus C plus C. That is 3C. Therefore, question is C1 by C2. C1 is what? C by 3. C2 is 3C. C cancels. 1 is to 9. So C1 is to C2 is equal to 1 is to 9 is the answer. Same problem. Okay. 15th problem. Last one. 3 capacitors C1, C2 and C3 are connected to a 6-volt battery as shown. Find the charges on 3 capacitors. 3 capacitors given. This is the diagram given in the problem. C1 10 microfarad, C2 5 microfarad, C3 5 microfarad. This is 6 volts. This is 6 volts. Okay, we have to draw an equivalent circuit. Wherever you are connected a battery, you come from the other end. Anytime when capacitance is connected like this, you start your equivalent circuit from the other side of the battery. Other side of the battery is this one. So this C2 and C3 are in parallel now. So I can write equivalent circuit. Battery, capacitance, these two are connected in parallel. Value 6 volts. C1 10 microfarad, C2 5 microfarad, C3 5 microfarad. So C2 and C3 are parallel. Therefore, Cp is equal to C2 plus C3. 5 plus 5, 10 microfarad. 10 microfarad. So, now the resultant circuit is like this. This is C1. This is Cp. These two are connected in series now. So I can write 1 by Cs is equal to 1 by C1 plus 1 by Cp. So 1 by Cs is equal to 1 by 10 plus 1 by 10, 2 by 10, that is 1 by 5. Cs is equal to 5 microfarad. So the resultant capacitance is 5 microfarad. Question is, you have to calculate the charge. In series circuit, charge is same. In theory of studies, capacitors when connected in series, the amount of charge across the capacitor or stored in the capacitor are equal. So, charge, total charge, Q is equal to CV. That is 5 into 10 power minus 6. Potential is 6 volt. So I can write 30 into 10 power minus 6 coulomb. That is nothing but Q1 across this. In this, the charge is Q1. Same Q1 charge here also. What is the value? That is also 30 microcoulomb. So C2 and C3 together 30 microcoulomb. Also, charges in C2 and C3 together is 30 microcoulomb. Therefore, C2 Q2 is equal to Q3 is equal to 30 by 2, 15 microcoulomb each. So total charge is 30 microcoulomb across first capacitor C1. C2 and C3 also 30 microcoulomb together. In that case, across C2 or in C2 15 microcoulomb, in C3 C2 15 microcoulomb, in C3 15 microcoulomb. So total charge together in the system is 30 microcoulomb. Correct? So the second part of electrostatics, that is capacitance and potential, we have seen the basic formulas and we have done around 15 problems. Basic problems we have done for you to understand. Okay. Next topic we are going to continue is current electricity and problems. First part, current electricity basics with the problems. First part. Thank you. We'll continue.